talked about parent functions and transformations. Now, out of all the families of parent functions that we have here, we mainly focused on three: linear, absolute value, and quadratic. Now, it's not that constant function isn't important, it's just not a whole lot happens with it, because we can move it up or down. That is literally it. We can't do anything else with it because it is constant. It doesn't change. It's a flat line. So our types of transformations that we had. So I gave us the general versions, or the our most basic, or kind of the general forms of all of these here. Linear was f of x equals a times x minus h plus k. Quadratic, f of x equals a times x minus h squared plus k. In absolute value, f of x equals a times absolute value of x minus h plus k. We did. So we had this from yesterday. So I'm filling this back in. Now, the other parts that we had going along with this was that h was our horizontal translation. It is our left or right, because our h is going to be the amount that we move left or right, and it's the opposite of what we think. Because it was, if it's plus inside those parentheses or absolute values, it's moving to the left. If it's minus 2, it's moving to the right. Opposite of what we think with left and right. K is our vertical translation. This is one that moves it up or down. Now, the nice thing with vertical is the amount that it moves is exactly what it looks like. If it's plus 3, it's up 3. If it's minus 7, it's down 7. Just like what it looks like. It tells us exactly what it is. And the last thing that we had was A. Now, the A that we looked at yesterday wasn't specifically about the value, the number it was its sign. Because if it is negative, then it is a reflection across the x-axis. It's a reflection across the x-axis. If it's negative, then it's not really focused on what the number is, if it is negative. So if it's a negative 2, it's a reflection across the x-axis. If it's just 2, there is no reflection. If it was negative 1/27, it's a reflection across the x-axis. It's not the number, it's the sign. Is it negative? If the value in that spot is negative, it's a reflection across the x-axis. Questions on this so far? Because I feel like yesterday we felt very good with up, down, left, right, and these reflections. Because what that brings us to is vertical stretch and shrink. Vertical stretch and shrink. Another way to transform the graph is to multiply all the y coordinates by the same positive factor other than 1. When the factor is greater than 1, the transformation is a vertical stretch. When the factor is greater than 0 but less than 1, it's between 0 and 1, it's a vertical shrink. And when we're talking about vertical stretch and shrink, again, vertical, up and down. If we're stretching it, it's going to increase faster. If it's a vertical shrink, it's going to increase slower. And it's all relative to the general function that we're starting with. Figure that out. So I'm going to just say x squared, graph. That's the parent function. That's the starting one. So, according to this here, A, the number in front of the x squared. If it's greater than 1, it's a stretch. Will someone give me a number greater than 1? 3. So 3x squared. This would be a vertical stretch. As we can see, the red graph is increasing faster along the y. That's why it's skinnier. Well, vertical shrink, it has to be between 0 and 1, yes? Well, 1/3. Let's use 1/3. Stick with the 3. 1/3 x squared. Graph. As we can see, the next graph is wider. It's increasing slower. And again, we're talking vertically going up as it increases along the y. If we look at the table, so the one in blue is our normal function. And we can see as the y values, as x increases, the y values for the one in blue are going 1, 4, 9, 16, are perfect squares. The one in red, instead of at 1, it's now at 3. Instead of being at 4, it's at 12. Instead of 9, it's 27. Instead of 16, it's 48. It's increasing by a factor of 3. It has a vertical stretch of 3. However, the one in black, instead of being at 1, it's now at 1/3. Instead of being at 4, it's now at 4/3. It's increasing slower. Actually, it's increasing slower at a rate of 1/3. 1/3 of the normal value. And that's what this is. That's what we're looking at. So, A, vertical stretch if A is greater than 1. Vertical shrink if 0 is less than A is less than 1. So if the value of A is between 0 and 1, it's a shrink. If the value of A is greater than 1, it's a stretch. And when we're talking about this, we're talking about the number, not the sign. We're talking about the number value of A, not its sign, is if it's positive or negative. What is that number? That's what we're looking at. Now, the pure definition of vertical stretch and shrink, I didn't technically write. You don't have to add this. I think we can deceive or be able to think about it just as a number, not with the sign, because the pure mathematical definition adds the absolute values. You don't have to add that. It's more, we're looking at the sign. And this is dealing with the reflection, because if A was -2, well, okay, the absolute value -2 is just 2, so 2 is greater than 1. We're just looking at the number. And that's why they include that there, is just in case the value of A is technically negative. Negative is not a part of vertical stretch or shrink. The negative with A is it's the reflection. The negative is purely part of the reflection. The number is our stretch and shrink. Now, if the number in front of it is 1, there is no stretch or shrink, because we're just taking all the y values and multiplying them by 1. That's one of the nice things about multiplying by 1. It doesn't change it. So if it's greater than 1, it's a stretch. If it's between 0 and 1, it's a shrink. If it's negative, that's a reflection. So they put the absolute value there just in case we're dealing with a reflection, because negatives with a reflection, the numbers are part of stretch or shrink. Do we kind of see that deviation between the two, the distinction? And that's why yesterday when I kept talking about reflection, it was not the number, it is the sign. Now, we ready to look at it, vertical stretch or shrink? A, g of x is equal to 2 times the absolute value of x. Well, this one's a part of the, or this one is an absolute value. Put the general form of the equation. A times the absolute value of x minus h plus k. Do we have an h or k value? No, it didn't list it, so that means it's not moving left, right, or up, down. Technically, there is a value for h and k, that value is 0. Because if I wanted to, I could say plus 0 there. Doesn't change it, because adding or subtracting 0 doesn't change the equation. So technically, yes, it would indeed be a vertical stretch of 2. So, and that would be the answer. And I'm going to get there in a second. But I'm saying that there because technically there is one there, but we're not going to list it. Does that make sense? And I made this analogy earlier, and I think it is on point with what we're saying. And actually, this is the first year I've used it. It'd be if someone asked you what you did yesterday, and you said, I didn't go to Walmart. I didn't go to Lowe's. I think it'd take about 1 or 2 of those, and then you'd be done with it. Because I'm not going to list off what I didn't do. We'll say what I did do. And that's kind of goes for this here. We're going to list what transformations did happen, not all the ones that didn't. And even if there is a 0, it's pretty much there is no transformation there. And yes, the only one we have is the 2. Yes? Since it's greater than 1, it is a vertical stretch of 2. I might have forgotten to say this in the other hours. We will have to write out vertical stretch. I've had some classes ask, some of the years ask, can we simplify it to vert S? Well, if we did that for vertical stretch, well, it could be vert S could be vertical stretch, or it could be vertical shrink. So at that point, just go on and write it out. Luckily, after this chapter, we're not going to, well, this chapter and the next chapter, we're not going to deal with vertical stretch, any of these transformations again. Yes. Let's look at the next one. H of x equals 1/2 x squared. This would be a quadratic. A parentheses x minus h squared plus k. Well, again, there's no transformation left to right, up, down, but we do have a value for a. And this would indeed be a vertical shrink of 1/2. Because the value of a is between 0 and 1, it's a vertical shrink. Since we have 1/2, it's between 0 and 1, it's a shrink. Questions on either one of those there? You feel good with those so far? Yeah, okay. Let's look at number 5. G of x equals 3x. So what family or what parent function would it have? Linear. Because it's just x. We don't have an exponent. We don't have absolute values. So this is linear. Now, again, I said this yesterday, we don't necessarily have to write the general form out every single time, but if you do find that helpful to attach what goes with what, write it out. Well, the only spot we have a number that deviates from the parent is the 3, yes? And that takes the place of A. So it's going to be a vertical stretch or shrink. And it's going to be a vertical stretch of yeah, that's it. Because it's just asking for the transformation. Because the transformations we've had so far are vertical stretch straight, reflection across the x, horizontal translation, and vertical translation. K is our vertical, our up-down. Well, there's nothing being added to it. Well, there is no up-down. Inside parentheses would give us left-right. There are no parentheses, so there is no left-right. The A value is not negative, so there is no reflection across the x, which leaves us with just the 3. So that is the only translation. It's just a vertical stretch of 3. Number 6. Well, we have a fraction, yes? So that means it has to be a vertical shrink. Yes? Or is it a stretch? Is 3 over 2 greater than 1? So it has to be a stretch. Yes. This is a vertical stretch of, yep. And again, I throw that in there just to make sure. I might do that every now and then. I will throw out an answer intentionally. If that's not right, call me out on it. Because again, just because it's a fraction doesn't mean it is automatically a shrink. We have to make sure the fraction is between 0 and 1 for it to be a shrink. And if it's greater than 1, it's a stretch. And there's different ways we can check and make sure. One of them is you can just type that in a calculator, 3 divided by 2, and look at its decimal approximation. Or here it wouldn't be approximation, it would be 1.5. Or, if the numerator is bigger than the denominator, then it's bigger than 1. Because it's our improper fractions. Questions on this here? We good with this here? All right, let's look at number 7. We didn't even write the general form for the last one. I'm going to write it for this here, absolute value. Well, the only thing we have that's being applied to this is the 0.2, yes? Which is going to be our vertical stretch or shrink. It's going to be shrink. Of 0.2. That's it. Questions on this here? So the first one was linear, the second one was quadratic, and the third one's absolute value. Yeah. We ready for the last part of this lesson? Now, it might have been interesting kind of why I've been writing the whole thing out, especially for the last one. If it's only a stretch, why not just write a absolute value of x, and that's our vertical stretch? Or same with horizontal, or horizontal translation, vertical translation, reflections. Why don't we just do one? Well, we can have more than one transformation applied to a function. We've been doing one at a time so we can focus specifically on each one before we look at multiple. So this here, our function, f of x is equal to times the absolute value of x plus 1. The general form, a parentheses x minus h plus k. So we do have multiple numbers that are being used. So looking through this here, we have a value for a, k, but not h. Well, what is our value of k? 1. So it's telling us it's doing what? It's moving 1 up, because k, up and down, is just like it looks. So one of our movements is up 1. There's no value of h, so it doesn't move left or right, which kind of the graph we can see. A's value is not negative, so there is no reflection. But a's value is 2, yes? Which means we have a vertical stretch of 2. And that's it. Vertical stretch of 2. So it's up 1 and has a vertical stretch of 2. Because the original parent function would be this here. So what we did is we moved the whole thing up 1 and then increased it faster by a scale of 2. That's it. We ready for the next one? Page. Identify the family to which G belongs. What kind of function is G? Quadratic. Two ways we can tell. One, we have the square. We have that exponent of 2. And 2, what kind of shape does the graph make? U. Makes a U-shaped graph. That is quadratic. So the parent function is quadratic. So I'm going to rewrite the general version of this equation here. Well, this time we don't have a value for K, so there's no movement up or down. But we do have a value for H, which means we're moving left or right. Which direction are we going? Because again, left and right is always going to be opposite of what we think, because it looks like it's minus, which would normally be left. So it's actually to the right. It's moving right. How far? 3. And we talked about this a little bit yesterday. And the reason it's moving right 3 is because, again, we're moving it based off the value of h. Our equation is x minus h. The one it gave us is x minus 3. The x's line up, the minuses line up. So the actual value of h is positive 3. It looks negative. So that's why we get that opposite direction. Because positive 3 is a right movement of 3. It looks like it's minus 3. Opposite of what we think. Now the other part we have is what? 1/4, which is going in place of A. Is it negative? So is there a reflection? No. All we have is a vertical stretch or shrink. And it would indeed be a vertical shrink of 1/4. And that's it. Questions on this here? You're feeling comfortable with these here? We'll look at one more of these. I will let y'all pick which one of these two we do. Do we want to look at g of x or h of x? Which one looks harder? G of x. G of x equals negative absolute value of x plus 5 minus 3. Well, its parent is the absolute value. This one here, we actually have a value for A, H, and K. Doesn't matter which one we tackle first. All right, go for it. So which one do we want to do first? Okay, so K tells us which direction. Tells us it's either up or down. So, and we're going to have a movement of 3, yes? So which direction are we going? Down 3, because it's minus 3. Because the nice thing about K and our up and down is exactly what it looks like. Since it's minus 3, it's down 3. If it was plus 3, it'd be up 3. Let's go to H next. Yes. Okay. Yes. So the plus 5 inside would be left, right, yes? So it's going to be a movement of 5. And it would be left, because since it looks like it's plus, yes. Since it's positive, we end up moving to the left. And the reason for it is our actual value of H is not positive 5, but actually negative. But again, it's sometimes easier to just remember opposite direction with left and right. Now our value of A, we have a negative. A is negative. And if it is negative, it is a reflection across the x-axis. Now, since the number in A's place is not something other than 1, there is no structure shrink. And that's it. Questions on anything we've done so far? The last one, I will give it to you because the answer for that is up 4, vertical shrink of 0.25, and a reflection across the x-axis. And that's what that is. Yeah, and we can specifically look at it. Now, the reason we have those 3 there is so the 0.25, negative 0.25, we have 2 things there. We have the negative and the 0.25. The negative, specifically the negative, is talking about a reflection across the x-axis. The value, the 0.25, does not connect to the reflection. The negative is telling us the reflection. The 0.25 is telling us the structure shrink. And it'd be a vertical shrink of 0.25. And then we would have up 4. Questions on any of those here? We ready for what's next? Homework. Problems 3 through 5, 9 through 15 odd, 19 through 25 odd, 27, 28, and 31. So the only ones that you do odd or even are the numbers that are right before odd or even. So 9 through 15 is odd, 19 through 25 is odd. Only reason I specify that is I've had some students turn in the entire assignment was just odd, but it's only that set number.